Camp Shelby, October 12, 1944. A column of weary men shuffled through a gate that smelled of oil and wet canvas, eyes hollow from journeys that had ended in fences. The morning light hit their faces at a strange angle, turning gaunt features into masks of disbelief. The roar of distant machinery did not sound like battle. It sounded like home for a different kind of war. The men stopped as if the sound itself had a name. A sergeant who had watched too many arrivals leaned on a gatepost and smirked, wiping a hand across his jaw that felt perpetually gritty with dust. He watched the prisoners cluster around a billboard advertising liberty in block letters and felt the familiar tug between duty and curiosity. He had been told to keep them under watch. Instead, he studied them. He studied the way their eyes moved, from the barbed wire to the silhouette of a factory ridge against the sky, and he felt the simple, irresistible pull of showing rather than telling. One of the prisoners, a former petty officer named Franz Mueller, muttered to his companion in a voice cracked with travel and disbelief, "You mean they build all that here?" The comment was not a question in the usual sense. It was an attempt to fold an impossible fact into the shape of his life. Around them, other voices rose in the damp air. The scene was almost comical at first. Men who had once targeted ships and airfields now gaped at assembly lines and cranes with something like the awe of children seeing a locomotive for the first time. The Americans had been told to expect suspicion and bitterness. What they did not expect was laughter that turned into silence. At first, the prisoners scoffed at sacks of stamped metal and crates that looked like furniture. They called the work crude. They compared it to things they had seen in their own industrial centers and found this to be mere abundance without glory. They treated the vastness as an insult to a European imagination trained on scarcity and craft. What none of them understood at that moment was that the scale itself was a weapon. The mountains of stamped parts, the rivers of rivets, the endless supply of standard steel were not accidental. They were deliberate choices of strategy. Machinery and logistics had been engineered to win a war of numbers and continuity. The irony was that what looked crude to the eye became lethal by quantity. A single rivet added weight and resilience. A single conveyor added hours of sustained output. Multiply those elements by thousands, and the result was capable of swallowing losses and spitting back replacements faster than any human fist could throw them. 3,800 rivets per wing panel. 56 processes from raw ingot to flight ready. 10,000 men and women working a single shift line that could turn a skeleton of metal into a functioning aircraft in less than 1 week. Those numbers were the language of the place. They spoke in tonnage and sorties rather than in duels and elegies. This story is about how scale and industrial logic overwhelmed expectation and rewrote the balance between individual skill and mass production. It is about men who had been trained to measure victory in maneuvers and marksmanship, confronting a reality where the measure was continuous replacement and relentless output. It is about engineers who thought in tolerances and colonels who learned to think in months of spare parts. And it is about the moment when prisoners of war realized that their idea of a front line had been reshaped by assembly lines and freight yards. How did men hardened by combat accept that what defeated them was not always a more daring formation or a sleeker machine, but a steady, grinding, often invisible machine of production that outpaced attrition? How did the shock of scale translate into tactics on the battlefield and policies in command rooms? Thousands of testimonies, letters, and reports will unravel that transformation in the account that follows. Sergeant Robert Hayes had been a shipping clerk before the war. He was not a strategist. His hands knew the smell of packing oil and the weight of ledger books long before they knew the weight of responsibility for a line of prisoners. He had been born in a mill town where the factory whistle was as defining as a church bell. As a boy, he had learned to read by the light that slipped through factory windows and had learned patience from men who timed every movement to the pace of a line. He enlisted because opportunity came in the shape of a uniform and a train ticket. He trained in logistics and then in management of captured personnel. The first time he saw a European prisoner stare for long minutes at a crate stamped with a serial number, he felt an ache that was neither pity nor triumph, but understanding. Hayes had married young and lost a child to illness before the draft reached his town. The memory of that loss sat in him as a small, persistent grief that sharpened his view of life as finite and fragile. His brother Tony had been injured in the Pacific and returned different in ways that family photos could not capture. Those losses taught Hayes to measure people by their small acts of endurance rather than by titles. At Camp Shelby, he became the kind of man who noticed how the same pair of gloves showed up in the same position on the foreman's bench each morning, and how a quiet adjustment in a ration distribution could ripple into morale. When the prisoners arrived, Hayes took an interest that looked like duty but felt like curiosity. He learned fragments of their stories in the brief exchanges during roll call. He learned that Franz had been an apprentice in a shipyard in Kiel, and that Klaus Richter had been a radio operator who read books about ships. He met Lieutenant Sarah Monroe, who ran educational programs for internees and who could quote industrial production numbers as easily as she could recite poetry. He met Foreman Earl Sims from the nearest wartime plant, whose hands had the tough knuckles of a man who had spent a lifetime in metal. Margaret Ellis, the engineer, oversaw a maintenance detachment and could explain in practical terms why a certain bolt design saved hours in rework. Colonel James Carter had the habit of tapping a fountain pen and looking at maps as if they were living things. Analyst Robert Caldwell in intelligence kept a small stack of translated documents that bridged the gulf between what doctrine said and what policies did. Hayes' backstory shaped how he presented the factories to the prisoners. He did not parade machinery as triumph. He told short, practical stories. He used language that translated measurement into experience. If a prisoner asked why the line used a particular jig, he connected that jig to hours of lost sleep by a mother making a child sling. If they asked about logistics, he explained trains as lifelines and packers as the men who kept a city breathing. These small human touches did not erase bitterness, but they opened doors to conversations that would later be quoted in debriefs and memoirs. The early tours were staged as demonstrations. A group of prisoners was brought to a small wartime foundry where molten metal glowed like an inhuman sun. The roar felt like thunder. Metal scent, sharp and metallic, clung to clothes and hair. Sparks flew in arcs that hung in the air for a heartbeat. The men touched a cooling wing spar and felt its residual heat like a brand. Voices were low and edged with disbelief. Franz ran a hand along a panel and whistled in a note that was equal parts admiration and mourning. In the first truly pivotal encounter, Hayes stood between a line of POWs and a bank of conveyors at Riverworks, where aircraft skins arrived by the minute. The scene needed a conversation long enough to allow disbelief to reshape into comprehension. Hayes led. "You're telling me this builds the whole plane here?" Franz asked, his voice thin and incredulous. "Yes," Hayes said. "The stamping, the riveting, the final fitting happens in sequence." Franz looked at the polished fuselage, half-formed, and then at a woman worker fitting a skin, and said, "But where is the genius?" The woman looked up, wiped her hands, and smiled. "It's in the planning," she said, "not in the tool. It is in the patience, in the schedule, in the way we keep replacing each part. The whole moves." Lieutenant Monroe added, "We practiced the sequence until the rhythm became an answer, not a question." Klaus asked, "How many of these do you make?" Hayes checked his tablet and said, "Roughly 300 a month." "Weak," Margaret chimed in. "That is typical for this line," Tony Rivera, the mechanic, said. "And if we run 2 shifts, you double that," Franz said. "You mean an army of metal?" Hayes nodded. "And an army of people," Margaret said. "We are as much a weapon as the guns." The conversation stretched long enough for each man to place a fact with a feeling, and for the sound of the conveyors to enter as a voice in their heads. That exchange was one of many that would expand into a new understanding. It contained 8 layered responses and pieces of information that carried both practical and moral weight. The sensory texture of the foundry was thick. Heat pressed against skin. The metallic tang of smoke and oil settled like a memory. The rhythm of presses punching holes created a percussion that matched a heartbeat. The sight of hundreds of panels stacked like a city skyline made an abstract number into a visible immensity. The tactile moment when a prisoner laid fingers on a riveted seam converted skepticism into a personal ledger of production. A technical aside explained the process in clear practical terms. A transfer press took a steel blank and, through a sequence of dies and punches, formed an airframe skin with tolerances of less than half a millimeter. The jigging system guaranteed alignment across multiple stations, reducing fit rework by nearly 30%. The assembly cell used a synchronized flow that balanced skilled tasks and semi-skilled labor to maximize throughput and minimize bottlenecks. Training accidents and losses accompanied the buildup of the machine. New recruits assigned to assembly often miscalculated rivet counts or over-tightened fittings, leading to structural rework. The human cost was not on the front lines, but on the shop floor, in backlogs, and in fatigue-related mistakes. Lieutenant Monroe recounted one incident where a supply error left a shift without critical fasteners. They worked late into the night, and 3 women collapsed with heat exhaustion. The event punctured any naive narrative of the system as infallible. It taught the men that scale depended still on human endurance and that vulnerabilities existed in the seams. The prisoners shared stories of their own industrial pride. Klaus remembered a dock where they had built a small class of escort vessels that had been his life's work. He spoke of finishing touches and of how the men there took pride in polish rather than in volume. That ethic collided with American practice. Where Germans prized precision and finish, Americans prized replaceability and rapid cycle times. The clash of industrial cultures revealed more than preferences. It showed 2 logics of war. One sought to make each unit an exemplar. The other sought to make each unit a node in a regenerating network. Tension rose in moments when ideology met calculation. On a rainy afternoon, Franz confronted Hayes with a question that carried more than curiosity. "Why do you make so many?" Hayes looked at him and said, "We can lose 100 and still fly 1,000. Franz said, "That is monstrous." Klaus said, "You replace courage with numbers." Hayes answered, "If courage is enough, then you risk everything on the slender thread of luck and leadership. If production can supply courage with a backstop, then you make losses survivable." The men fell silent. Rain drummed on the roof, and the smell of wet earth mixed with oil. That pause was tight as a wound. It lasted like a held breath, and then shifted into a more pragmatic conversation about supply chains and the meaning of victory. There were at least 4 such tension moments in Hayes's experience. In each, the structure was similar. A moral or aesthetic claim triggered a memory in a prisoner. That memory became a personal ledger. Hayes responded with a practical option, often invoking logistics or production data. The result was anguish, followed by a decision to either reconcile or resist. One such moment involved a broken bomber wing that arrived at the camp previously claimed by an overrun factory. The sight of a mangled skeletal frame prompted a hospital-like hush among the prisoners. Some wanted to keep the piece as a memorial. Others advocated scrapping and reuse. The debate reflected competing values on loss and reuse. In the months following that first season, Hayes and his small team became intermediaries between 2 industrial worlds. They arranged tours to different plants. They staged comparative demonstrations. Robert Caldwell used translated documents to show prisoners estimates of repair rates and time to replace lost squadrons.
Colonel Carter organized briefings that showed how shipping tonnage equated to days of sustaining an offensive. Foreman Sims ran practical drills that let prisoners handle tools and see the speed of a practiced crew. Margaret Ellis taught a small class on tolerance stack-up and why certain bolt patterns save time in inspection. The tactical adaptation story was not immediate. Commanders learned that attrition had to be measured against production curves. Bomber wings adapted escort strategies knowing that replacement aircraft would arrive in predictable cycles. Fighter units developed rendezvous patterns that preserved leverage over points of production rather than merely chasing kills. The lesson was that logistics could be targeted to disrupt the rhythm as surely as bombs could destroy a plant. The first time intelligence found a choke point on a rail route, the emphasis of an operation shifted from point attacks to interdiction. Hayes watched maps while the planners argued about probabilities and felt the same old ledger of the mill town where a single bridge closure once cost his neighbor weeks of wages. Demonstrations at scale created shock. A convoy of newly produced cargo planes flew low over a training field, and the prisoners were invited to watch. The sight of dozens of clean airframes taxied in procession had visceral force. Some prisoners wept. Others looked away, as if to avoid the stitch of sorrow tautened by the sight. The statistics behind the scene were blunt.
The plant had produced 700 cargo planes in 6 months. Each plane could carry 4 tons of supplies, and each week the convoy meant an additional 2,000 tons of material in theater. To an internee whose world had measured success in sorties that required artisanal repair, this looked like magic made mundane. Adaptations continued as engineers on both sides found workarounds. American designers simplified maintenance panels and standardized fasteners to reduce time in the field. A short technical note clarified the change. Standardizing on a single bolt head reduced tool inventory and changed turnaround time on field repairs from days to hours. That small engineering choice showed the link between design and battlefield endurance. Meanwhile, other theaters forced variance and experiments. In the Pacific Islands, where distances and salt air eroded structures, a different logic applied. Corrosion-resistant alloys and longer-range fuel tanks were prioritized. Hayes visited a coastal repair depot where Japanese prisoners had been assigned to work under supervision. They named themselves with a mix of pride and resentment and told stories of carrier decks and night raids. The diversity of needs across theaters illustrated how a single production model could be modified into many. Engineers like Margaret and foremen like Earl had to adjust workflows to cope with climate, salt, and long shipping hops. Each variant taught something back to the main line about resilience. Counter-responses from Axis Command tried to reassert a qualitative edge. They invested in jet prototypes and special armored interceptors. Reports of jet encounters spread fear that a qualitatively better machine could overturn the arithmetic. The reality was more complex. Jets required specific fuel materials and complex production chains that the Allies countered not only by bombing but by targeting supply nodes and the specialized workforce. An episode at Osterfeld where a prototype jet was captured and examined provided critical intelligence. Robert Caldwell and a team of technicians cataloged materials and found procurement patterns that revealed vulnerabilities to supply cuts. Production numbers tell a harsh story. By late 1944, American plants had turned out tens of thousands of aircraft and millions of components. Numbers were not mere trivia. They were explanatory. They showed why a single campaign could not rely on a sudden spike of quality alone to change a strategic balance. They also explained why attrition rates could be absorbed without a complete collapse of operations. The human side never vanished. There were funerals for factory workers killed in mishaps. There were letters home from those who found meaning in welding and assembly. There were prisoners who later recounted that seeing a production line helped them reconcile defeat by understanding the scale at which a democracy could commit resources.
At roughly 1/3 into this narrative, pause, we should step back for a moment. If you were surprised by the images of prisoners staring at assembly lines, you are not alone. Historians and veterans continue to debate whether technology, tactics, or sheer production shifted the
balance. I want to hear what you think. In the comments below, tell us which factor seems decisive to you. Start your answer with one of these words: technology, production, or tactics, so we can see patterns in opinion. Your words help shape future episodes and highlight perspectives that deserve deeper attention. Now, back to the story. The production story accelerated into showpieces intended to demonstrate capacity. Massive parades of material were staged for Allied eyes and for the prisoners who were sometimes invited as observers. These parades had political aims, but they also served to inform tactical thinking. A display of motor transport convinced planners that rapid mobility could be sustained. The sight of uniform crates and spare parts stacked in efficient geometry convinced others that persistence mattered more than perfection. There were also moral frictions. Some prisoners found dignity in learning new skills on the line and later applied those in post-war reconstruction. Others resented being turned into hands for a machine they had once resisted. Hayes observed both reactions and kept a ledger of small acts that revealed larger trends. For example, Franz later would write in a memoir that he had found comfort in the rhythm of presses. Klaus would write that he had felt robbed by the commodification of craft. These personal arcs mattered because they connected policy to human adaptation. The climax of the industrial argument occurred when Allied air interdiction campaigns sought to break a specific supply chain. The operation targeted a rail hub and a nearby machine shop. Intelligence had shown the hub to be critical, and Carter argued for a concentrated effort. Analysts pointed to replacement rates and to possible civilian consequences. The raid succeeded in interrupting shipments for 3 weeks. The effect was immediate. A forward unit reported delayed spare parts that required cannibalizing 1 damaged aircraft to keep 3 airborne. The arithmetic turned visceral. The planners learned that while production could absorb attrition, the system was only as strong as its nodes. Post-raid adaptations involved dispersal of small workshops and redundant supply caches. Engineers redesigned components to allow substitution of different alloys. These procedural changes revealed an industrial learning curve and the flexibility of an ecosystem that could absorb shocks and evolve. There were encounters with jet-powered interceptors over contested skies. The first report of a jet sighting created a panic in a squadron that had believed the comfortable calculus of altitude and escort. A pilot named Leonard Hayes, not related to the sergeant, described the jet as a silver wedge with no tail sound. The material analysis that followed showed that the jet's advantage would be temporal unless supply lines could be secured. The Allies responded by focusing on denying rare materials and on attacking assembly niche shops rather than large plants. Production and logistics imprinted themselves on strategy. The final months of the war showed a pattern. Allied victory was not simply the result of superior aircraft or singular tactics. It was the result of an industrial ecosystem that could sustain losses and learn quickly. Where Axis forces had relied on exceptional designs and constrained production, the Allied approach used redundancy and rapid replacement as strategic assets. A technical description clarifies one design decision that shaped the outcome. The adoption of a modular subassembly meant that entire flight control surfaces could be removed and replaced in the field with basic tools. Module interfaces used standardized fittings and a color-coded system that reduced diagnosis time. This change cut turnaround from multiple days to a single shift in many depots and proved decisive in keeping squadrons operational during peak campaigns. The human toll remained plain in statistics and in small stories. Plants recorded accidents and fatalities. Families wrote letters. Work shifts extended into long nights. Yet that same workforce rebuilt fleets and cargo planes and trucks that kept armies supplied. The sheer scale created a moral paradox. The machine demanded human labor, which in turn made the machine possible. After victory in Europe, there were formal debriefs where prisoners of war were asked to report their impressions. The testimonies were consistent in theme.
Franz said he had been stunned by the coordination more than by the machines. Klaus said he had been humbled by the scale and the sight of ordinary women working on critical systems. Others, like Paolo, an Italian engineer named Marco, and a former sailor named Otto, offered variations on the same disbelief. The epilogue follows through short temporal snapshots to show consequences 1 month, 3 months, and 6 months after the critical period. 1 month later, there was a tentative exchange program where selected prisoners were allowed supervised internships in repair depots to learn skills and to help clear backlogs. That program reduced immediate repair times and allowed for quicker repatriation planning. The prisoners who participated carried back knowledge of processes that later became part of reconstruction efforts in their home regions. 3 months on, the industrial conversation shifted from wartime urgency to peacetime planning. The same assembly principles found their way into commercial production. Engineers like Margaret Ellis published papers on modular assembly that influenced early post-war aviation design. Foreman Earl Sims and his crew received commendations, and many of them returned to civilian factories where they helped transition tool rooms to produce consumer goods. The shared practical language between former enemies facilitated exchanges that aided rebuilding. 6 months on, the larger strategic narrative took shape. Official reports and memoirs placed industrial capacity at the center of Allied victory. Governments recognized the need for maintaining a robust manufacturing base and for training a workforce that could pivot in crises. Former prisoners returned to countries in ruin, and some used their experiences at Camp Shelby to advocate for new labor models. Others struggled to reintegrate. The moral and economic aftershocks persisted for years. Statistics underscored the narrative. American aircraft production by late 1944 exceeded the combined output of major Axis producers. Spare part inventories and rail improvements cut average repair
Downtime by weeks in many theaters. Thousands of soldiers and civilians had moved through wartime production systems and carried those skills into the post-war economy. The scale of output became a strategic doctrine rather than a temporary expedient. In conclusion, the scene that began at a dusty gate with men staring at a factory ridge ended in a wider transformation of how wars could be fought. The Axis prisoners could not believe the scale because their mental models were anchored in a different industrial logic. The American approach turned factories and supply networks into strategic instruments. It did not render courage obsolete. It redistributed risk. It demanded labor and logistics, and it taught commanders to think not only in maneuvers, but in months of spare parts, and in the resilience of railheads. The riddle remained in the memories of those who saw both sides. Franz Saar's later letter to Hayes read in part, "You showed me an assembly line, and I saw a future that was less glorious but more survivable." Hayes kept that note in his wallet until his death. If this story moved you and you want to explore how technology, production, and tactics interact in the making of history, then subscribe for more deep dives into the machines, people, and decisions that changed the course of wars. The story of scale is also the story of people who built and who endured, and that is where any true account must begin and end.